Hey everybody, welcome back to the shop. I have a personal project that I'm going to get started on this morning. I have a part here that I designed specifically for a one-use application, and that is to be able to hold our Starlink antenna on our RV. So I've got this piece of aluminum block here that I cut up, and we're going to machine this to hold a piece of aluminum tubing, which is also going to hold the Starlink antenna on top of that. The intentions is this block, once we get this machined, is going to bolt on to the front of our RV. I have a tray, it's called a trailer tray, on the front of our RV that holds our generator. And on the side of that, there's a couple mounting plates there. It's a universal bracket system, so anybody can mount this on whatever travel trailer you have. So there's a bunch of holes that's not being used in this plate. And those holes would be a perfect location for this block that I'm wanting to machine right there. So this will get milled. We're going to have a hole pattern machine on the back of this so that I can stick it up to that plate, and I'll have 4 5/16 bolts that actually hold this block in place. It's going to be bored through here and split with a couple of cap head bolts so that I can take the aluminum tube that I have, which is going to hold the antenna, and I'll be able to set it down in here and tighten up the 2 clamp bolts there to tighten up the tube and hold it. So here's a print that I made. We used Fusion 360 to make this drawing right here. This was some more of my training. You know, any opportunity that I get to train on Fusion is what I'm trying to do here. So I took the opportunity, designed this block right here, and then went into Fusion 360 and did some more training with Kevin at mechanicaladvantage.com, and he helped me with this program right here. And this is not going to be a CNC program. I want to do this on our manual mill. We're going to use our KBC mill to do this, but I made 2 drawings right there. This one is going to give me all of my specifications that I need for all of the features that are machined in there, like the drilled and tapped holes, the bored hole, the split, all those kinds of things. I wanted one that had just your basic outside dimensions, which is what we have right there. Kind of have a clean print, you know, just for a cut and mill specification, and then all of our detailed prints on a separate one like that. So I'm going to show you the post that I'm going to use. I think it's kind of unique to me. It's a piece of material that I've had in my possession, that my dad has had in his possession for many times, including my granddad. So this particular aluminum tube is seriously going to a 3rd generation use, and I find it really cool. So I'm going to show you that, and then we'll get started on the machining for this aluminum block. So here's our Starlink antenna right here, and this works perfectly fine just like it is, and we've used it several times. This has really been extremely helpful the past couple of camps that we have gone on, being able to have connectivity to the outside world, being able to get on our YouTube, upload videos if we want to do Instagram posts and things like that. This has been extremely helpful. And we're getting ready to go on this year's big haul. Big haul is what we call our big road trip that we try to take every year, and we typically been doing that in the spring. So we're getting ready to take off on our big haul, and this is going to be a new addition for this year's big haul. The previous years, all we had is our cell phone and a hotspot, which proves to not be very useful in many of the places that we have been. And this year we're going to be in a lot more remote locations than we were in the previous years. We're going to be doing some dry camping, some boondocking, camps like that. I'd also have a portable power supply that we can run off this guy as well. It's just a portable battery system that we can plug the Starlink into at any time and use it, and it's not draining juice off of our RV battery. So anyway, what I wanted to do was be able to take this guy and get it up high, about even with the height of our RV. And to do that, what we're going to do, I'm going to go ahead and just flip this guy upside down. Actually, what we'll do is I'll show you. You push this little tab here, and you can slide it out of the base, and this is how you actually put the Starlink away, okay? So you have the antenna here, and then you have the base, all right? So I am wanting to get this guy mounted up higher, so I needed a piece of tubing that I can slip this down into. which is what we have right over there in the hardtail vise. We'll show you that in a minute. And I'm going to take that piece of tubing and machine it so that it fits the bottom of this Starlink antenna right here. So you have we're gonna have like a keyway. I'll mill a slot in there and make a 7/16 key to line up on this guy right there. And then there's this tab that when you slide it down into the base, it catches the little edge right here, okay? So to release it, you push it in and you slide this off of the base. So we'll machine the end of the tubing to fit this right here and mount that. And then so what we'll do is stick this in the to the tube, and it'll raise the tube all the way up, which this is gonna put this just above the height of the RV. And then what we'll be able to do is then stick the tube over there down into the post that I'm gonna be machining that's to be mounted on the front of the camper. This piece of tubing is what I was talking about, that this is now being passed into the third generation and being used. And what I find very unique about this specific piece of material is not that it's a piece of aluminum tubing. It's the fact that my granddad used this for his camper as well. This piece has been in my possession for a long time, and there was actually several of these pieces of tube. I want to say there was probably at least 4 or 6 of these things, and they've been used for various projects and stuff over the last 25 years that I'm aware of. This is the last one that I still had remaining. I had it on my metal rack outside, and whenever I found it, it ended up being the perfect piece of material that I was planning on buying a piece. And then when I found this, I said, this is exactly what I need. It's even the right length. It's 6 foot long, which is exactly what I wanted it to be, is a 6 foot long piece of material. So what I have done is I set this up in the Victor lathe at the home shop, and I sanded the red paint job off of it that my granddad had put on there. He had them all painted red. So just used some emery paper, got rid of the red paint, Scotch-Brite to kind of polish it. And you can see there's a couple holes drilled in this in. I'm not sure exactly what granddad used these tubes for, but I'm almost positive that what they were used for was like a tent or a canopy. I think he had some kind of canvas canopy system where he had these poles that he would stand up in all the corners and hold the canopy up. And I believe that's what this was used for. All right, so here we are several decades later. I'm gonna be using this same piece of material for our camper on RV to hold a Starlink antenna. Now, who would have thought that would have ever happened? I just find that really unique there. But I'll show you, I think you guys will be able to see this. You can take this post and it fits down on side that Starlink antenna. Not perfectly, but really good. I mean, it's got slight more looseness than what this has right here, but it's gonna hold just fine. And so I'm gonna machine the end of this guy. Like I said, it'll have a key in there and it's gonna have a slot milled in it so it catches this. I think what we'll do is just, instead of using the side with the holes, we'll use this side right there. I'll mill a key, or I'll mill a slot. I'm probably just gonna TIG weld an aluminum key in there to match up with that. And on the opposite side, we're gonna have a little slot milled in there so that when it slides down, it'll catch that little lip right there and hold it in place. And other than that, once we pick it up, we'll be able to pick this up and stick it down into that block I'm gonna machine, tighten it up, and there's our Starlink mount right there. All right. So I'm ready to get going on it. Let's go to the KBC mill and start making some chips. Just another close up here real quick before we get started of our dimensions. I wanted to point out that the outside dimensions of this block is not critical at all. We've got these just set to a nominal size, but we'll just get this guy milled down. We're not gonna worry about hitting it within a thousandths because there's absolutely no need. The most critical dimension on this is probably going to be my bolt pattern right here, which is actually going to match up with that plate that's on the RV right now. And of course, we want to get a good fit on our bore right there too. So I'll have to actually mic the tubing, and we're going to give that probably a, let's say, a 5/1000 slip fit down inside that. I don't want it to be too tight, and then we'll split it so that it'll clamp down on that post whenever it goes down in there. Couple of tapped holes there just for our clamp. So you can see nothing super critical, but The location of the hole pattern and the location of our bore through there is going to be real critical. So we'll get this block milled in the mill, and then we'll go to the lathe. We'll probably lay out a center position of this hole, and then we'll go to the lathe, the manual lathe, and use this to get this guy bored out. I do have a shoulder in the bottom so that whenever you slip the tube down inside the bore, there's a shoulder there to hold it in place and keep it from going all the way through there. That's all it is, okay? I am going to use, we've got this Walter 3-inch face mill that we'll be able to use on this block right there that we cut, and I do have some aluminum specific inserts that we're running on this. This is the insert number right there that will be running from Walter, okay? One other thing I want to point out, this is a block of aluminum that was given to me by Doug Jackson, SV Seeker. He's been anchored off in Pensacola Bay over here, or Big Lagoon, for, I don't know, probably a good 6 to 8 months now. And he had a couple big pieces of aluminum flat bar that he wanted to donate to the shop. So he stopped by, this was several months ago, he stopped by and dropped that block of aluminum off. And I cut me a piece out of that. And that's where this aluminum come from. I believe it's 6061 aluminum. So big thanks to Doug for donating that block of aluminum. It's gonna make one heck of a nice project there. All right, we've got our mill all ready to go. Our vise is already trimmed. I've just lightly deburred the block so that we don't have burrs that we're sitting on. We're gonna start by getting it squared up. The block is gonna end up being 2.5 by 3.5 by 4, okay? So we're just gonna get in here. We'll get it milled. I'll rotate it like you normally would a cube there so we can get it all squared up. And then the thickness there, we'll end up milling down to 2.5 inches. But to be 2.5 by 4 inches, and then the other dimension is going to be 3.5 that way. So we'll use this little piece of brass rod in here so that it pushes. We want it to square up on this back jaw right there. And using the rod there is going to allow for any kind of misalignment of the two surfaces here for our jaw, and this surface being parallel with each other. Take about a 50 thou cut. I left it so that it had 1/8 of an inch to clean up. And we'll see how those aluminum inserts do. Just getting my depth set here. I'm probably going to go ahead and run this mist on here too, just to kind of help keep it lubricated as it's cutting. Should be able to run through here very quickly with this face mill. And it's going to make a mess, but I expected that. We're just going to make one pass across this block here to get it cleaned up. So I think what I'll do is I've got a center established there. Take just a little bit longer, but we'll move it off halfway so we're not cutting into what we just cut here. How about that? Let's see how that goes. Not running very fast. I got it set at 600 RPM, but you can run these guys as fast as you want. So we'll take it out and rotate it. What I'm going to do is walk over to my buffer polishers. I got a 3M deburring wheel on there, and I'll use that to deburr these edges and then come right back and then we'll rotate it that way. All right, got it deburred. The buffer just makes really easy work of that instead of having to hand file it every time. And then so that was our milled side. We'll go ahead and rotate it back. Try to get our block nice and square. This is where the piece of bar, any kind of dowel or rod that you put in there, we'll tighten up on that cut side and push it against our machine side. Let's go up a couple hundred. There's 800 RPM. This is the side that's going to end up getting quite a bit milled off. I just want to clean it up though, so let's just come across, go right down the middle of our uncut area. All right, deburr it and rotate it. All right, that's the side we just milled. First side, second side. This will be our third side. You can see the indentions of the rod across there, how that wasn't. This bandsaw cut's a little bit wavy because my blade has gotten dull. So we'll rotate it in there like that. Put our rod back in there. We'll clean this side up and then I'll measure it and we'll make this one to our, let's see. This one's gonna be 3.5 since we already got that first one milled. And we got about a 1/16 left. Let's just take 40 thou. All right, I've got our stare at depth mic here we'll use to measure the thickness of our block. All right, we've got 26 thousandths to come off of there. We're right in line with what I was measuring with the scale. Just double check that real quick. Yep, 26 thousandths to bring it to 3.5. So that was going to be our finished dimension of 3.5. We'll see where we landed. Like I said, these outside dimensions are not critical at all. It's just a nominal that I wanted to make it to. Let's see how close we got. Within a couple tenths of being 3.5 inches. Plenty close enough for what we're doing. All right, we'll get it deburred, rotated. Now we'll get it down to our 2.5 inch thickness. I'll show you guys how I'm deburring this. Just using the Baldor buffer here. This is a 3M Scotch-Brite wheel that I run. I buy these off Amazon. I think they're around 50 or 60 bucks a piece, and they work great. Gets that edge right on off there. All right, we got her clamped in there. No need for the rod now that we have 3 square sides there. This is going to be our 2.5 inch thickness that we want. So we can start taking some heavier cuts on this side. Let's try 125 thousandths and see how the mill and the face mill handles it. There's our touch off. Get a 0 on the knee right here. All right, let's see. 125 thousandths. Let's get our mist going. Slow it down just a little bit. It was trying to chatter just slightly. I can see it in the cut there, but not a big deal because we will obviously take a lighter cut to clean it up. That was my final cut on the 2.5 inch side. So let's get a measurement. We'll use our depth mic again here to see how thick our block is. It looks like it's dead on 2.5, maybe 1/10 off. I'd call that good enough. All right, we got our block clean and deburred. We still have one factory mill side right there. So this is gonna end up being our 4-inch length. So what I'll do is go ahead and we'll just set it down on that factory extruded side and tighten her up. We'll mill the bandsaw side first and we'll flip it over and clean up the last side there. Just run it right down the middle, take a 1/16 off of it. All right, we got our block deburred. We're gonna do our last side there. So this is the side we gotta cut. Get it down in there. Need to go change the rod on my depth mic. Looks like we got about a 1/16 to come down off of it. So what we'll do is just go ahead and take 30 thou, about half of it, 10, 20, 30, and then we'll mic it. Would help if you go in the forward direction in fast mode. Okay, let's make our finished cut on the milling here. We got a 4 to 5 inch depth rod on here. We want to make this 4 inches. Let's see what we got left. .26 thousandths. Do it one more time. Make sure there's no chips on the bed of the vise there. I got about 26 and a half that time. All right, I'll try 26 and a half on the dial here and see if we can hit it on our 4-inch mark. All right, let's measure it. I bumped the rod, so let me do that again there. You got to be careful when you take these things off your measurement. It looked like it was within a half a thou. Yeah, I'd say that's probably about 3/10 over or 4 inches. Again, well within the tolerance of what we want for that block. All right, so we'll take this guy out. I'm going to go ahead and deburr this side, and we'll probably go ahead and move on to our hole pattern that we got to drill and tap in it. We're just going to find the very center of the block. We'll use our stared edge finder for that. And our DRO by using the half command. So that puts the center, X and Y, and then we'll step off each side. We're gonna have a 4-hole pattern that's symmetrical to the center of the block. So we got our DRO in the center there. I like to put my XY movements on one of these sticky notes here, and I just put it right up here underneath the readout. And so it'll be a plus and minus on each direction there, but that's our XY coordinate that we're gonna be doing. So according to our print, this is the hole pattern that I come up with that's on that plate on the RV there. So we have a center to center, 3 1/16 one direction, which will be an X. And then our Y is 1 1/4 center to center, which is gonna be 0.625 in each direction. So it's just real handy to be able to look up there and know exactly what our X and Y is supposed to be on. So we'll move X, which is the top number there. And then Y, so we'll go to this back corner, start at 625. I keep overshooting it. There we go. That's close enough. We'll do that times 4. Okay, we're gonna use a split point drill there, stubby drill, so I'm not gonna worry about centering or spotting these holes. We've got a depth set at 1 inch up here on the quill. Let's go for it. I think what I'll do is go ahead and we'll run our cool mist again. Instead of any kind of cutting fluid, we'll just use our cool mist. How about that? Let's see how that'll do. Quite nicely. All right. We're gonna go to plus 625. plus 1.531. Minus 625. All right, now we'll do a chamfer. All right, we're gonna get our chamfer set. What I like to do is come down solid on the stop on the spindle and bring the knee up to the desired depth. And I'm not even gonna measure it. We're just gonna eyeball this on something that looks good. So I think that right there looks pretty good. Now we can just come down to our stop every time. All right. So I don't think I'm gonna fuss with tapping in the mill. I think I'm gonna use my flex arm for this. It's a perfect job for that. So we'll move on to the next machining op. Let's just go ahead and get this guy tapped. We're over here on the flex arm table. All right, and we've got a 3/8/16 spiral fluted tap. We'll use the power tap that, and we got some anchor lube here that we'll use to lubricate the tap. All right, let me get the air gun and blow those chips off, get them out of the way. It definitely hit the bottom, but I didn't have the clutch didn't exactly clutch the way it's supposed to, but that's okay. So this is why I decided to do it in the flex arm. It's just faster and easier.